Good afternoon, everyone. Thanks for joining. My name is Dan Malouf, Senior Director of Product here at Eins. Excited to be hosting this week's tech briefing. As a refresher for any new folks on the line, the purpose of these 30-minute briefings is for a rotating cast of Eins faculty members to dive into the relevant news, InfoSec news stories of the week. So vulnerabilities, breaches, all that good stuff, and provide you with specific actionable guidance to take back to your teams. That is the backdrop. Thrilled to be joined today by two of our Eins faculty rock stars, Jake Williams and Gal Spancer. Jake is an independent security consultant and former startup founder with decades of experience in technology and security. And Gal has been a full-time security consultant since 2000, providing guidance to early-stage tech startups, security vendors, Ivy League universities, nonprofits, and Fortune 50 clients. Jake and Gal, thanks so much for joining today.
Thrilled to be here.
So with that, let's take a look at the agenda for today. Three stories that, have kind of been making some news over the last few days or last week or so. First, we're going to talk about a critical vulnerability in Shim that could allow a network attacker to bypass secure boot and take over a vulnerable Linux system. After that, we're going to discuss two new unpatched bypasses for a critical remote code execution vulnerability in FortiSIM, which is Fortinet's SIM solution. And finally, you guessed it, more Ivanti talk. We'll cover the latest news here, what's going on with Ivanti. I mean, I feel like we talk about it every week at this point, but it's definitely worth getting different perspectives. And the news keeps changing on a daily basis with them, right? So this is sort of an evergreen topic for tech briefings going forward, I would imagine, but more on that.
I mean, it's not like we want to keep talking about Ivanti, right? They keep forcing our hand. They're like, we're like, hey, we're going to stop talking about you. Ivanti's like, hold my beer, right?
Exactly. Right on. All right. Well, with that, let's just dive right in. Jake, I want to start with you if I can on this Shim vulnerability. What's going on here? What's the deal with this?
Yeah. So Shim's really this is such a disaster from Shim's overall, or such a disaster from a design perspective. These things really come out of the fact that we have lots of Linux distros, and how do we effectively, with secure boot, ensure that every Linux kernel, is able to, secure boot? How do we validate the integrity of that thing? Because that's what secure boot's supposed to do. And so Shim was a service that was designed to do exactly that. It also, for lights out reloading and kickstart style operations, has to support HTTP boot, right? Or HTTP boot and which, by the way, pivots well into Pixie fail, which we talked about a few weeks ago. That booting ultimately, or Shim service, has to support that HTTP boot, or secure boot and Shim can't work together, right? So neat, but here now we have a vulnerability in the way that the HTTP headers are parsed. They potentially can allow threat actors full control over a Linux machine. Now, I have good news. The good news is, in enterprise environments, which is the vast majority of everyone on the line here, you probably don't have this turned on in your data centers. If you do, now, again, some telcos, some remote, particular remote site folks may, but the big takeaways here, right, and the reason we included this story is because of the takeaways. First off, go back to your folks today and ask, across our Linux ecosystem, how many of our Linux systems actually are enforcing secure boot? I'm guessing the answer is, based on my experience, I'm interested in Gal's experience as well, the number is very low. Gal, what's your take on this, man? For secure boot, is it necessary? Should we have it enabled? Is it really low in Linux environments?
Without knowing too much, I think the default answer, I agree, is you need to inquire within and assume that it's not on by default. I think one of the interesting things, I did some work for a kind of thin client, zero client vendor about 13 or 14 years ago. And they were doing a lot of interesting stuff around Pixie, so remote boot type of stuff. And it was a hardened Linux kernel stack kind of thing. And it was interesting to see a lot of kind of high security environments really interested in, hey, how do we do thin client or even zero client kind of remote boot type of work? And it's interesting to see this kind of still pop up.
Yeah.
The idea that I think the vast majority of people, even in the cybersecurity space, who haven't had an occasion to dive into these depths kind of below the OS and into the firmware and the boot chain. I started playing with that stuff when I was doing a lot of work around full disk encryption. And so we would intercept the pre-boot chain to say, hey, who are you? Are you even allowed on this box? And that was before the operating system.
Mm-hmm.
So it's a fascinating kind of dark ocean Marianas Trench type of work that the vast majority of people have never done.
Right.
I was doing some work in 2017, I think, when Intel finally admitted what I think a lot of us suspected but never confirmed, that there is a web-enabled null auth authentic, zero auth kind of issue around, hey, I can talk to your firmware over the
Yes.
web
Yes.
below the operating system. So even if you had like EDR and all this other stuff above, you were potentially compromised there. And in a way, it's almost like OT level exploits where we can just
Yep.
reflash your firmware or reflash your OS. So I think it's an interesting thing from an awareness point of view of where is that part of the stack relevant to our environment, and how do these vulnerabilities affect us, if at all? And there are some good vendors who've been specializing in this. And I think this folk came out of Intel, and there was an open source project around this stuff. So, it's its own kind of lesser addressed thing that I think is really interesting. And you won't know that you're compromised. Your EDR won't help you, right? Because it's literally below the radar there.
Yeah.
So interesting stuff that I think is something we need to take a look at from, is this even on the radar of the security program? And in many cases, it's not, because we're trying to figure out like identity and AppSec and, open buckets and someone got root on our AWS or has domain control and is ransomware. So it's an interesting niche.
Yeah. You were talking about some vendors that have spun out of this. I worked with the folks over at Eclipsium for several years, right? And they're probably the go-to, right, in that space binarily as well. And so it's really, the attack surface is huge, right? But just noting that really does sit in the too hard bucket for the vast majority of organizations. I do want to highlight for the folks on the call here, kind of like secure boot, aren't all boots secure? That's actually what secure boot's supposed to fix, right? Is that, that what Gal was talking about, that root of trust, right? All the way from loading an operating system, are these components supposed to be here? Now, this is not going to impact, right? A secure boot bypass generally is not the kind of thing like ransomware groups directly are looking for. This is heavy nation state stuff typically, right? And these are the folks, though, that once they gain access to a system, you're not getting them off the system because they're loading before your EDR is. And that's really where we come back around and say, hey, really take a look at this from a Linux perspective. The other big takeaway I want to highlight here for folks is that this vulnerability was originally reported as and hyped as a Red Hat vulnerability. And only about a week later did folks kind of circle around and go, this stuff is in more than just Red Hat. And the reason for that is that Red Hat maintains the actual Shim package that's used by lots of other Linux distributions. And so this is another thing that I go back to your vulnerability management teams and say, hey, when did we recognize this was on the radar for us? And then compare that to when this was publicly disclosed. Because if it was on the radar for you at all, right, it probably happened if you're talking about Ubuntu or Ubuntu LTS or SUSE, or a Debian distribution. You probably found out about it a week or so after the disclosure. And there's probably some lessons to be learned here, right? Either talking to your VM vendor or your vulnerability intelligence team or what have you to shorten those timelines as well.
Yeah, I think in some cases, one of the things you might want to take a look at is just the idea of PXE boot. It's called PXE pre-execution environment, or PXE. So if you just kind of ask your server management people and maybe even your hardware vendors, if you have a data center that you buy hardware, ask your Dell or HP or whoever it is that's supplying you that stuff, and ask them about the remote management of the kind of the server environment itself. There's a lot of interesting stuff, DRAC and so on. It's its own kind of specialization where a lot of people think, oh, we've just abstracted above that. At the end of the day, even the big hyperscalers have to deal with this stuff. It's just abstracted away from us, so we don't have access to it. But if we're running our own data centers, we should understand what's at that kind of pre-boot execution environment. And a lot of times there's something listening for a patch, a wake on LAN, or some other thing like that.
Got a quick follow-up question, Jake. Do you want to just answer it live in the chat?
I don't know is the short answer, right? So I'd have to
question
go.
Is,
I'd
does
have
it
to go
does
look.
this apply to Bastille? Yeah.
Yeah, I'd have to go look, but I think the answer is presume yes, right? Presume yes if it's a Linux-based OS that is running that's using secure boot, right? FreeBSD is not, and that's why I'm pretty confident it doesn't apply there. But yeah.
Gotcha. Awesome. All right.
Want to
Well,
hop
I
up
do
to
want to.
Fortinet?
Yeah, let's hop up. Exactly. Good call, Jay, keeping us on time. Kyle, do you want to start on this one, sort of talk through, what's going on here? What's kind of the high level takeaways on this one?
Sure. So similar things on the server side, right? But in this case, we have our space heaters. I mean, appliances that are giving us theoretical protection, but in some cases, the bad guys know that, hey, this stuff is internet exposed, and it is the concentrator for the VPNs and the remote access and a lot of the policy enforcement between the big bad internet and supposedly the secure inside the LAN. So these are quite common, and sadly, the biggest usual suspects have these things. So it's not just Fortinet, it's Cisco, it's Palo, it's all of them. If there's an appliance on the internet, whether it's on a VM or a piece of hardware, you're going to have problems with it because someone's going to do the research, find it, exploit it, and then toss a grenade over the shoulder and give it to everybody. So that's what happened here, and it is a full kind of remote takeover of your Fortinet devices, potentially. If you're running 7.6 FortiOS, then as of now, the latest version, they're not vulnerable. TBD if that stays that way, but there will be more vulns because again, these things are sitting on the edge of a lot of networks that are getting attacked, and so someone's going to figure something out. So really, I think that the question here is, with other managed file transfers, with all of your kind of perimeter VPN concentrators, firewalls, IDS, IPS, even WAFs, what is it that we want to know that would indicate to us that this thing got taken over? How do we do good architecture around, hey, this something that is protecting us on kind of the castle wall is eventually going to be breached and taken over potentially, and how does that affect our security posture? Do we have DRBCP? If we need to shut down SSL VPN, for example, on this Fortinet, which is one of the mitigations, what would that look like in terms of a tabletop exercise to assume that that's going to happen to us? If not through this Fortinet today, then through your Cisco or your Palo or whatever other VPN concentrator you're looking at. Which brings me to another kind of more theoretical troll question is, what is the point of VPN in 2024, right? Like, do we want old school VPN users coming into our network at that level of the stack, or do we want something else, zero trust, more app layer stuff? So I think that's an interesting question, and I think you should use, as a blue team, architects, CISO, even firewall engineers, hey, is this the best way to do this kind of work, remote access and firewalling and policy enforcement at the boundary? Is this the best way we can do this? Are there better, different services, even from the same vendors? They can abstract away some of this stack that is sitting on the internet and waiting to be attacked with these kinds of things. So not to pick on Fortinet, but just in this case, it's very important to patch, but others will have the same problem. What does it mean to us from an architecture going forward?
And I am happy to pick on Fortinet, actually. This is so very specifically, and I'm going to deep dive just a little bit here because Paul has already covered. Look, we did have I actually had a call yesterday with an IANS client, Ask an Expert call, where they were talking about Ivanti, which we'll get to in a second, that they have a big deployment of and across lots of different sites. And the answer, I told them, like, if you're worried about this happening again and again and again, you should be. But the answer is ZTNA. The problem is the time to have started with ZTNA is probably 18 months ago, right? Because it's not a quick evolution in the vast majority of cases, right? Now, there are some use cases that I can, that I don't have to do an all or nothing solution. I can do I know this is a big one here, reducing attack surface, right? By moving some percentage of my users off of those VPNs and possibly shutting some of those down. But yeah. Well, let's talk about the vuln itself, right? Gall mentioned that FortiOS 7.6 is not vulnerable. Now, I have unfortunately been, I've had to reverse engineer pieces of FortiOS in the past, and to say that it is an old tool chain or built on old tool chains, and I say in the past 2 years, it's built on a decade-old tool chain, right? Decade-plus old tool chain. So when I learned that the specific vulnerability in the SSL VPN side is a format string vulnerability, right? I was not surprised, right? Now, I want to level set here and say that we should not have format string vulnerabilities in 2024. And in fact, you shouldn't have had format string vulnerabilities at all in the 2010s. The tool chains were built to stop those explicitly. For those that aren't familiar, right, this is, and I want to like highlight a big win here because, I know I'm kind of pooping on Fortinet a bit here, right? But why is 7.6 not vulnerable? Do we think that they magically went through and updated all of their, all of the various printf statements and sprintf statements and whatnot that lead to format string vulnerabilities, or did they change the tool chain? And if I had to guess, I'd guess they changed the tool chain and upgraded to a modern compiler. We have a very concrete example of this in Windows. If you look at Windows XP and Server 2003 and before, the sort command on Windows is vulnerable to format string attack. Microsoft does not change the code at all, right? As we move up to Vista and Server 2008 and whatnot, same vulnerability exists, but the modern compiler doesn't allow it to be exploited for code execution. And I suspect that's exactly what we're seeing here, right? Is a modern tool chain, right? The same compiler steps in and is like, oh, let's not do that, right? Let's not set that up, right? And this happens time and time again, right? Now, obviously, Gall covered a lot here with, the specific issues around some of these VPN appliances and managed file transfer appliances. You got to have a plan in place to threat hunt. But I want you to look at the meta side of this as well, because there's a huge DevOps lesson here. Very often we get tied to particular tool chains, right? And when I say tool chain, understand that means a development environment, a compiler, linker, specific sets of libraries, right? And then we don't move up on those libraries because everything's convenient and it takes more time to make that work and refactor for something that is working well enough. But you don't get the security features that are baked in by default on those newer tool chains. I'll grab money right out of the wallet here, drop it on the table here, and say I'm willing to bet all of that 10 to 1 that a tool chain update is what keeps 7.6 not vulnerable here versus the other versions. So anyway, wanted to go ahead and throw that one down there as the big DevOps takeaway also, while we're kind of focusing on VPN.
Let's hope that's the case. We won't see the same thing happen again. And maybe other vendors will take a look.
Jake, you want to start on this one?
Yeah, I mean, look, I don't even know where to start, honestly. The Ivanti, my friends, what are you doing, right? Even pre-purchase of or pre-acquisition, of the Pulse Secure line, there's they still have code and tool chains there that are just decades old. And when I say decades plural, I'm not exaggerating. The Perl build in the Pulse Secure appliances right now, or the Pulse appliances, is 23 years old. So it has numerous vulnerabilities, right? If I've ever seen a case for SBOM, this is it, right? This is, I mean, I'm channeling my, my inner, my inner Alan, right? And thinking SBOM, but we need SBOMs, right? There's no way you deployed this stuff with known exploitable vulnerabilities, right? Of these different libraries if you had an SBOM for these appliances, because it's not like we're 1 or 2 patch cycles out of compliance here, 1 or 2 decades out of compliance, right? There's a reality to refactoring a code base that is decades old. The folks who wrote this are no longer anywhere to be found, which means that folks are having to learn this code. And as they update these libraries, which they are going to be scrambling to do, they will introduce new vulnerabilities. When's the last time CUSA said patch and then, oh, by the way, patching isn't good enough, rebuild your appliances and get really good at it because you're going to be doing it again and again and again? Paul, over to you, man.
Yeah, that's really interesting. I think SBOMs are becoming more of a popular concept, certainly an interesting thing in terms of the kind of what ingredients are in my system here, right? And maybe the lack of transparency allows vendors, in some cases, the one we're talking about today, to get away with more stuff than they would otherwise. And then, we just don't know what's going on here. The issue of transparency potentially could be interesting. And it's interesting that, you mentioned also that when you fix code, you're creating additional code, which has its own percentage of whatever by line or by a new library integration, its own new vulnerabilities. And there's the whole the way the system is affected as opposed to just the new code. So that's why I think it's really interesting to think about what are these types, categories of systems doing for us, and how do we abstract away from them? And in some cases, it's the same vendor in a different presentation. And in some cases, it's going away to not just their next competitor, but rather an entirely different thing. And like you mentioned, ZTNA and the whole zero trust networking piece. But just, one of the interesting things that I saw, you mentioned Eclipsium, not as well-known kind of niche cool vendor. I think another not as well-known niche cool vendor is Velexity, and they're the ones who found the Ivanti problem in December, and they have a really good, interesting 3 or 4 blogs about this now. And they mentioned that some places that were running a freshly deployed Ivanti Connect secure VPN appliance, they applied the mitigation, but then were recompromised. And so there's apparently a sequence that you have to follow, and I can get Daniel the specific blog I'm talking about here, so everybody will be able to see that to add to the write-up. But it's really interesting to see that just because there's a mitigation out there doesn't mean that it's properly applied or in the right sequence to fix the exploitable bug. So that's an interesting thing that around, what is the discovery of the fix? How do they find it? A lot of memory analysis, one imagines, given what they do. And then the question of they've seen exploitation post-patch with a freshly mode appliance. Really interesting stuff.
Look, I can't be like, I'm not going to get into any specifics, even, and I don't know all the specifics on all of these, but I'm confident that there are vulnerabilities that have been reported to Ivanti that have not yet seen the light of day on the basically on their VPN appliances, right? And so again, this is a trend that's going to continue. I don't know how else to say it other than, again, I even went so far as to say I think this is an Accellion all over again, right? I don't see the Ivanti Pulse line coming out of this without a rebranding, right? Accellion doesn't exist as Accellion today. It's Kiteworks. And so, and even that was a transformational, when you really go hard on getting in with secure dev, right? It's a 12 to, usually a 12-month evolution, right? To really get an SDLC in place where you haven't had one before. Gall mentioned you introduced some number of new bugs, and as you're updating code, well, sure. And that's in the best case scenario where folks are familiar with the code. That's not the case here. It's clearly not the case here, right? So some of this code, again, folks haven't touched it in, very likely in a decade plus, right? And so again, I have very, very low confidence here. And I don't know what else to say other than, if you're running these, you're a sitting duck.
The next time we have an Ivanti story in the tech briefing, hopefully, no, it's not relevant to anyone, right? I guess.
Yeah, I hope so. Well, but there's a secondary piece here too, right? You say not relevant to anybody. You may not be running this. It's still very relevant to you, right? Because your business partners are the folks who are processing your data. These third parties processing your data. Your SaaS provider, right? Ivanti. One of the reasons that they get a lot of business, right? Let's be real. Their stuff is priced well. Obviously they can afford it. They're clearly not paying devs, right? So, anyway, sorry, I didn't mean to be pithy there.
No, that's it. Yeah, it's a good point, though.
But your suppliers are actually running this stuff, and so you have to reach out and ask, right, from a security perspective. What's your security posture around this? What are you doing? Because otherwise, again, this is just third-party risk management, embodied.
Gal, any final thoughts or?
I'm just looking at the Ivanti.com/products, and it is a long list. And yeah, again, re-architecture, long-term, short-term, patch, understand the specific sequence apparently of this patch. Otherwise, it won't be as patched as you thought it was or wanted it to be. And then, understand what does this thing do for me? How do I assume breach of this and other appliances? Really, obviously, anything else, and start implementing some concepts around trusting these things less as security appliances and more as things that will be exploited because we trust them too much in some cases.
Right on.
Yeah.
Jake, final words?
Yeah, I mean, look, two final words there, and you know, Gall, you really you know, inspired me on the first one here, and that's that. Look, you know, when I'm saying this about Ivanti, I'm not talking about all of Ivanti's products. I haven't looked at all of Ivanti's products. Just the, I keep saying Pulse, it's Connect Secure now, but the you know, the Connect Secure VPN. So that's specifically what I'm talking about. They acquired that product. You know, obviously, they haven't, you know, again, demonstrably. Haven't maintained that product or brought it up to, you know, modern library levels. I can't speak for any of their other stuff, though. It might be perfectly secure, and maybe it isn't. I don't know, right? That's a bigger discussion to have with them. Finally, though, right, what Gall said, that's got to be probably your biggest takeaway, right? Even if you don't run Ivanti, right? It's the managed file transfers. It's the stuff that has to be exposed to the internet, right? And those exposures that you have there, you got to step back and say, okay, expect these devices to be hit, right? And when they're hit, right, then have that telemetry in place, whether that's NetFlow, you know, whether that's, heck, I'm talking to clients that are looking to put web application firewalls in front of some of their SSL VPN appliances, right, to, you know, manage the login pages. I see Gall looking like
very meta, very meta. Yeah,
no, I
I
agree.
don't
It's a
know.
bad plan, right?
I'm open to suggestions.
Yeah. In some cases, though, it's the best bad plan we have, right? And so, you know, I mean, hey, again, you know, bottom line though is you got to architect for defense, detection, and investigation.
Yep.
Question in the chat just to end here. They've only really spread to other Ivanti products other than the original two.
No,
Not that we know of yet. Yeah. Cool.
Yeah.
Awesome.
that's a huge
Well,
footprint. So,
yeah,
you know,
yeah, yeah,
so
yeah.
just with the original two, yes.
Cool. All right. Jake and Gall, thanks so much. Appreciate it as always. Thanks everyone for hopping on today. Good discussion as always. And yeah, we'll see you all next week.
Excellent.
Appreciate
Thanks,
it.
Dan.
Thanks.
Thanks,
Thanks,
Jake.
guys. Take care.
Guys.
Bye.